Hi, in this video I'm going to focus on something that looks like a bug in temporal tables in SQL 2016. Now while this feature is new and there is obviously going to be fixes that will be implemented, I just wanted to highlight this because it's probably easier to explain with a video rather than to kind of demonstrate it using the blog. So here I've got a virtual machine that's already set up with SQL 2016, and I'm going ahead and creating a temporal DB database, and I'm going to use it. And inside of this database I'm going to create a visits table, which is my temporal table, and a visits underscore history table, which is my archive table. You'll notice here that I've used start time and end time with the date time 2 precision 7, which is the default, so that goes down to the nanoseconds. And I'll go ahead and do that same thing here where I just say date time 2. The reason I'm doing this is because this will become important to kind of explain what's happening with regard to the bug. So as you can see here, I've got two tables. It's got visits and visits history, ID, first name, last name, email, gender, and IP address. And then I've got a start date and end date, standard implementation that we see typically for archival and audit scenarios. So once I execute this script, we've got this table created, and I'll insert some data into the history table as well as some data into the visits table to kind of simulate some existing records that are already there. And when I execute it, you'll see that we've got the data populated in both of these tables, and so far everything looks good. Now, as you can see, I've used datetime with the datetime 2 with the default precision. So when I execute this table that says the script that says alter the table visits, you'll see that the default datetime that they expect to be passed does not contain milliseconds or nanoseconds. And when I execute this, I'll get the error message that says that the date time period is not equal to the maximum value for date time over here, which is what they're expecting in this case as this value. Now this becomes important, so what I'm going to do is I'm going to go ahead and fix this with the standard example that they've given on the MSDN websites as well. So to do that, what I'll do is I'll just go ahead and drop this table, and I'll create it again. Oops, actually before I can create it again, I'll probably need to go ahead and drop the database because the date time timestamps that already exist are now invalidated. This becomes important because a check is implemented before it actually does the temporal changes. So I'm going to go ahead, create this database again, and I'm going to use it, and I'm going to create my visits table. And this time when I create the visits history table, I'm going to make it date time with 0 precision over here. So that's good. And then I'm inserting the data like before and verifying that everything is good. So that's all fine. And here now I'll go ahead and make this date time 2 because the data types need to match in this case. If they don't match, you'll get an error saying that the schema is different or the columns are different. So this is again one of the limitations, or not exactly a limitation, but one of the rules that get enforced when you're creating temporal tables. So you can see that I'm getting an error message here that says that the records are out of range. Okay, so it's saying that there are open records with the start time set to the future value, and that's probably because I'm using sys UTC date here. So let me just go ahead and change that to get UTC date. Again, the dates need to be perfect so that it'll actually go through, because it does check for overlapping dates, which is one of the reasons why there's a warning on the website where it says that changing the date or system clock of your server will actually invalidate the rows, and that will cause an issue. So there we go, that's fine. And then we go ahead and do this, and we bind the temporal table with the history table. So far this is what you need to do to implement temporal tables, and that's all fine. The challenge that you'll face is if you see here right now, I've got, oops, just a second. if you see here, I've got one example where I've got an entry called Jayanth, which is having an IP address of 192.168.1.1, and it's then got a historical record which is 192.168.1.0. So I'm going to go ahead and increment this to 4 now, because that's the next IP address in the sequence. So you'll see that I've inserted one row here, 4, and that's again I've created a new record. So when you create new records, nothing happens to the historical table, as you'll see here. I've just got one new entry here. But when I take this and I update it to 5, as you can see here for the ID 1, you'll notice that 5 also goes through, and you'll have 2 records now over here. One is the first entry that we had, then the second entry, and now we got 5 here. So far this is all good, because this is how we expect temporal tables to behave. Now what I want to show you next is, if you see here, I'm going ahead and updating the IP address for the record 1 twice within the same batch. So you'll see that basically it's right now at 6, and then I'm going to take it, make it 7, and immediately, almost within the same fraction of the second, I'm going ahead and changing 7 to 8. So in this case, what will happen is, if I do this like this, you'll see that I've got 8 recorded over here, and then I've got 5, 6, and 7 recorded over here. So as far as the insert operation is concerned, you'll see that the data looks perfectly fine. Everything seems to be working the way it's supposed to. But now when I come into the querying part of it, when I'm looking to query the data from the temporal tables, here's the challenge that we'll face. For example, you'll see that these two guys have the same timestamp, right? So if I go ahead and say show me all records where the start timestamp is from this value, which is 1341, and you can see this is 42, so I'm going to make it 45. Yeah, so I'm going to say that show me everything that happened between 141 to 145, and that's basically all these records here, because all of these guys have a timestamp less than 45. So if I select this and execute this, what you'll see here is that I've got the IP address 1, 2, 3, 4, 5, 6, no 7, and then I've got 8. So the question here is that as soon as these two records come as part of the same batch, or basically as part of concurrent sessions, or essentially the row gets updated very quickly, one after the other, the loss of granularity at the date time column kind of limits what gets returned as part of the query. And I'm not sure if this is expected behavior, but if I'm going to use the temporal tables for data warehousing applications, especially for some kind of message framework where I might receive a lot of messages coming in fairly quickly, then I would think that losing some of this data is not really gonna help my data warehouse. So I would believe that in this case, if you're going to look at this timestamp range, then technically the 192.168.1.7 IP address should also be listed here, and that's where I think there's a bug going on here. And I'm obviously going to raise it in Connect just to see exactly what Microsoft thinks about this, in terms of whether it's expected behavior or whether there's something else going on that probably we need to consider. But I hope you found this interesting, because it's something to watch out for in case this is not fixed. But if you find a reason why this would actually work, and this is genuinely expected behavior, I'd be really interested in knowing how you plan to account for it, because this is normally the kind of issue that you wouldn't face with something like change data capture or the trigger based approach. So I hope you enjoyed this video, and thank you for watching.